Good afternoon. It was my pleasure to share with you for what I have learned in schools and several projects I was involved in the past. Before we talk, let's talk about the difference between the structural engineers and us geotechnical engineers. So if someone asks, what are you geotech engineers doing differently from structural engineers? A likely answer could be this. The structural engineers know how to do calculus. They know how to solve differential equation. But for us, the geotech, we only do multiplication and additions. At most, finite difference, all right? So let's check how valid it is. For all of you geotech, if this answer fits what you practically are doing in every day, raise your hand. Oh, not very many. That's good. So apparently, this answer is not fair, right? So in this way, we will need to find a better answer. So a better answer could be like this. When people ask, then you just say, look around. When you see the building, what you see is designed by structural engineers. What you do not see is designed by geotechnical engineer, all right? So, when you fly to Boston, during the landing, look over the window. You see the wastewater treatment plant facilities in Deer Island. That is the Boston Harbor Project, which was one of the largest single projects of public works in New England, and the second largest of its kind in the nation when it was completed in 1999. However, you do not see there is a 9.5 miles offshore effluent outfall and the diffuser tunnel 240 feet under the ocean floor that you don't see it. Then, if you ever drove to I-10 in Escambia Bay, Florida, in 2007 around, all right. Then when you drive onto the newly constructed bridge, you may see under an existing bridge, there is a retaining wall there you almost see every day when you drive through the highway. But it looked like a regular MSE wall, but you did not see there was a temporary shoring stabilized by mechanical plate anchors during the construction of the roadway widening. And there's a permanent tie-back anchor social pile wall behind that panel that you didn't see. Then, when you look over the I-595 in South Florida, which is a corridor improvement project, probably is one of the largest one in the P3 project, public-private partnerships in the nations, which was completed in 2014. However, you do not see there are so many deep foundation piles or even micro piles which are supporting the bridge structures. So, let's talk about, before we share about the subject, the movement matters and the interaction with structural engineers. Let me share with you a story happened 35 years ago. There's a group of graduate students, smart ones, all right, in Virginia Tech. In the classroom, in the deep foundations, one by one, go up to the podium to present his or her resolutions for the deep foundation design, the homework assignment by Professor Mike Duncan. At the end, Professor Duncan shared with all of us, say something like this. For all your presentation, all your solutions, none of them is proper. You have, as a geotechnical consultant and engineer, you need to have a guts to tell your clients, saying, this site, even the deep foundation, it doesn't work. Or even tell them, I don't have a solution for you. Please consider change the project site. These answers may not hold true today, because there are so many specialty contractors techniques in these days in our toolbox. However, the spirit learned from the classroom keeps on moving. So in one day, in a project meeting for design of a temporary shoring right next to a hospital surgical facilities, An excavation temporary shoring needs to be done. Then, in the meeting, the structural engineer says, you design for a temporary shoring system. You should design a system to allow zero movements surrounding your excavation and the existing structures. So with a pause, I say, no, it's impossible. Practically speaking, nobody can do it, all right? If there is a stress, either loading or unloading, there will be a strain, there will be a movement. So, no, I couldn't make it based on your specification. Then the structural engineer turn around and say, tell me how much it will move, all right? In general, movement prediction to be reliable is usually not an easy task, all right? People may ask, and also, what I learned from school, want to be a geotechnical consultant is this. Never say a specific number of settlements in your recommendation. Always say a range, all right? From 1 to 2 inches, because of the uncertainty there. And the structural engineer may also ask other questions. Please tell me whether the foundation subsoil will be liquefied or lateral spreading or not. The answer is yes. Then the tough question is next. Then tell me, what is your anticipated total and the differential settlements at the site? Because I need that information to design my structures. Then you need more analysis and more uncertainty in there. They may even ask, can you drive the pile to capacity? Answer is yes. Then the question is, can you tell me, during the pile driving, what is the potential ground movement surrounding the pile driving, and how will it impact the adjacent existing structure? We have effect to it. Then that's another tough question, all right? In practice, there are methodologies, there are semi-empirical correlations that can be used to predict, to provide a reliable predictions of such movements. For theory and methodology, such as developed by Professor Wayncroft, Professor Jonathan Bray, and from Dr. Bent Felenius. If you go for the state of the art, would like to find out even more detail, then you may consider, let's go for finite elements, or go for the finite difference. So, in 1990, there's a project for the wastewater treatment plant facility expansions, which is one of the largest wastewater treatment plant in Midwest in the US. The project is very challenging, have different type of construction, like deep foundation, shallow foundation, ground freezing, soft ground tunneling, and sinking caissons. This sinking caisson is 140 foot inside diameters, 7 thick wall, sinking in stages into the hard pan through the soft clay with an undrained shear strength of 370 to about 700 psf, sinking step by step down to 80 feet, sitting landed on the hard pan down below, which I believe this caisson still holds the record as one of the largest in North America. So in the project, there's a challenge. There is a retention system there need to be designed. However, this retention system need to be done to limit the movement to protect the adjacent tunnel, which is a live tunnel, which serves about 50% of the city's millions of people. So that's where my first job is, working as a resident engineer, cranking the number of the finite element analysis using the soil struct. You may be familiar with that 30 years ago, all right? One day, something happened, all right? The tunnel moved, then everybody stopped. All jobs stopped. And then structural engineer, geotechnical engineers, and the contractor talk about what to do. Eventually, we modified the design and the finish in 24 hours, not 24 hours, running 24 hours, no stop, and until the finish to seal off the bottom. All right. And interesting worth mentioning, for this project, Dr. Ralph Peck, the famous observational method pioneered by him by 1969 was extensively implemented in this project. And he was also consulted to establish the Earth pressure diagram to design the semi-rigid Earth retention system. Then let's move on. 2000 till now, I have been working on several highway design build projects. In the project, oftentimes the question is this: structural engineers, please tell me, what is the tolerable lateral deflection of a pile foundation subject to lateral load? I don't get a direct answer. Usually they turn around to you. You tell me how much you will move. All right, so no answer. Then iteration starts. All right, and interestingly, in ASCE, the ASCE related to the deflection of the pile, they're talking about two requirements. So first, you need to design the pile to the depth of the fixity to check the buckling of the structures and the lateral stability. The second criteria is you need to penetrate the pile to the minimum pile tip elevation to obtain fixity. With this fixity term in the requirements, it's oftentimes confusing to people. So over the years, not only structural engineers, geotech engineers ask the same question. Tell me, where is the point of fixity? This terminology come up. Then let me give you a quiz, a Geo-PIT quiz. Since Geotechnical Engineer Circular number 1 to number 14, there's a number missing over the decades. Which number it is? Never published until 2018. It's number 9. All right? The number 9 published first time in 2018. They talk about the confusion terminology of so-called the fixity. Then there are so many different terms. So if people ask the question, I will first ask the structural engineer, where is the point of fixity? Tell me what you are looking for, what you are doing for. If you are doing for the buckling, check. I will have at least 3 answers for you, 3 different answers for you. Then if you are talking about the overall stability of the pile, lateral stability associated with the lateral displacement, then I will have 8 answers for you, all different. All right? Then if people keep on digging, then tell me which answer is the correct one. Then remember the story, the spirit I learned from the very beginning. Allow me to tell you my tentative answer is, I don't know.